All right, so we're going to talk about um 6.2 similar figures, okay? So, similar polygons, similar figures, kind of the same thing. Similar polygons are polygons with the same shape, but they have a different size. Okay, so they might be the same, like they might be two triangles, they might be two squares, they might be two hexagons, but one's going to be smaller and one's going to be bigger. Okay? Polygons are similar if two things. One, the corresponding angles are congruent. So corresponding angles are congruent. Oop, I forgot to put angles. And two, corresponding sides are proportional. Because remember, they're not the same size. So the sides can't be the congruent. They have to be proportional. So corresponding sides are proportional. Okay? The ratio of corresponding sides is called the scale factor. So basically it's a factor, not factor, sorry. It's a fraction of the corresponding sides. And then if polygons are similar, then blank are also proportional. Remember that sides add up to equal perimeter. So if polygons are similar, then their perimeter will also be proportional. That's why you'll see some questions that ask you to find perimeter, given perimeter of one of them and then sides of another. Okay. So now let's talk about scale factor. As we said, the ratio of corresponding sides is called the scale factor. So one huge thing to know about scale factor is that order matters in basically two ways. Okay. If you remember our congruency statement, triangle ABC was congruent to triangle DEF. The order mattered because if A was the first letter in the first triangle and then D was the first letter in the right triangle, then those were congruent. So that's the first thing that matters. Okay, so what is the scale factor of triangle ABC to triangle DEF? Well, remember the scale factor is a ratio of corresponding sides. So it's a fraction of sides. So pick your favorite side. You can pick AB, BC, or AC. I'm personally going to pick BC. And if we look over here, BC is congruent to, not congruent, it's proportional to EF because BC was the last two letters, and EF is also the last two letters. So those are proportional. We also know they're proportional, not even just looking at those letters, but if we look, these are congruent, and then these are congruent. So basically, it was green to blue, green to blue. So that's one way to think about it too. So triangle ABC was written first here. So I'm going to write it first in my fraction. So 10, and then DEF was 15. Now, that's a fraction, and it's not simplified. We always simplify our fractions. So if you put in your calculator 10 divided 15, it gives you a decimal. Then you hit math, enter, enter, and it'll give you a simplified fraction, which will be 2 over 3. Or you can just simplify it in your head if you're cool like that. So, that's the scale factor of triangle ABC to triangle DEF. Now, if you look at this next problem, it says, what is the scale factor of triangle DEF to triangle ABC? So here, the orders switch. So possibly the order might switch on our scale factor, but let's check it out. So remember, it doesn't matter what side you start with, as long as you pick the side it's proportional to. Okay, for example, in this case, since DEF is used first, I'm going to go triangle DEF. We can pick side DF, which is 21. Okay, if we look, it's in between the 1 arc and 3 arc. Well, in between here, the 1 arc and 3 arc is 14. So those are proportional to each other. You also could look at the letters, but So this time we have to write 21 first because DEF was written first here. So 21 over 14, and when we simplify it, it's 3 over 2. So here the fraction flipped because the order it was written was also flipped. So again, that's important. Remember we said if polygons are similar, then the perimeter are also proportional. So let's see what the ratio of the perimeter of triangle DEF to triangle ABC. Remember we find perimeter by adding up all the sides, right? So if we did 12 plus 15 plus 21, we get the perimeter for triangle DEF as 48. And then we find the perimeter of ABC, we would do 8 plus 10 plus 14, which is 32. Now, again, order matters. They listed triangle DEF first, so I'm going to put that up top. And then over 32, and that reduces to 3 over 2. So that checks out because, as we said, polygons similar, then the perimeter are also proportional. So basically, they're going to have the same scale factor, the sides and the perimeter. Okay, which that will be important on your quiz and whatnot because you use perimeter. I mean, you'll use scale factor to find some perimeters. So, similarity statements. What is the symbol for similar? This one's really easy. So, you know the symbol for congruent. It's a squiggly line. Ooh, that's a terrible squiggly line. A squiggly line with an equal sign under it. Well, remember, similarity does not mean equal. So we take away the equal sign, bam, we have the symbol for similar. So, just like how we wrote a valid congruency statement, a valid similarity statement must match all corresponding angles and sides. So we saw up here, angle A was congruent to angle D, angle B was congruent to angle E, and so on. So we would have to write that triangle that's literally a B, ABC is similar to triangle DEF because those angles were congruent to each other, but also AB was proportional to DE. So now let's list all congruent angles and write proportion that relates to the corresponding sides. We're not writing that the sides are congruent because they're not. They're proportional. They're similar. Okay? So listing all congruent angles is pretty easy because angle J is congruent to angle P because J is the first letter, P is the first letter. So angle J is congruent to angle P. Okay? Now, angle K is congruent to angle M for the same reason. K was the second letter, M is the second letter. Angle K is congruent to angle M. And last but not least, we have angle L is congruent to angle N. Last letter, right? Angle L is congruent to angle N. I feel like that's the easiest thing we've ever done. Now, let's write proportional sides, okay? So let's start with the smaller triangle first, the one on the left here. And let's start with JK. There's multiple ways to think about this. Okay, you can either think about JK being from green to blue if you color coordinate like mine, or you can think that JK is the first two letters, PM's also the first two letters, and we look, it's from green to blue. So JK goes first, and then over PM, okay? And then order matters, we had to write the small one first, then the big one, because of similarity statement. Okay, let's keep going. Now let's do KL next. Again, you can either think of it as from blue to like whatever color that is, maroon, blue to maroon, or you could think of it as KL is the last two letters and N is the last two letters. So you write that as KL over MN. And last but not least, we have JL over PN. I did not highlight that one. because JL, green to maroon, or first, last letter, first, last letter. Easy peasy, right? Alright, let's move on to the next question. So, if you look here, the triangles this time are on top of each other, not like separate. So it's a little harder to see, but if you highlight it, this is one triangle, this big one. And then we also have this, oh, that's the same color. You also have this smaller one, okay? It's a little bit helpful, especially when you're working on your classwork and whatnot, because sometimes they'll have 8 and 20 over here. 20 is the side of one of them, but then 28 is this one, right? Because it's 20 plus 8. So that's something to keep in mind when doing your classwork and whatnot and your homework, and then on your quiz. So, anyways, that's not the point of this problem, but I'm just pointing something out. So, let's see what angles are congruent to each other. So, according to our similarity statement, angle X is congruent to angle R. So, angle X is congruent to angle R. And then if we look, angle Y is congruent to angle Y. Now, you might ask how an angle can be congruent to itself. It's because the two triangles share the same angle. Okay, they both share angle Y. So it's actually possible depending on how the graph looks. And last but not least, we have angle Z is congruent to angle S according to our similarity statement. So angle Z is congruent to angle S. That was the easy part. Let's move on to proportional sides. So again, it might be easier to look at the similarity statement for this one, but XY, if you look, is the first two letters. First two letters on the right one is RY. So XY is proportional to RY equals. Then we have YZ is proportional to YS. So YZ over YS. And then we have XZ is proportional to RS. So XZ over RS. And that's it. All right. I'm going to let you guys do number 3 by yourself, so please pause the video and then do it. But before you do that, if you look, how many sides do these shapes have? They have 4 shapes. Okay, so that means you should have 4 answers over here. Okay, so pause the video and then come back. Alright, so I went ahead and wrote down the angle congruency. So angle J was congruent to angle Q. Angle K was congruent to angle R. Angle L is congruent to angle S, and the angle M is congruent to angle P. And again, you can just look at the similarity statement to easily see that. But I wanted to like work through the side proportions so you can do it with me if you were confused. So clearly we have side JK. Okay? JK is the first two, QR is the first two. So JK is proportional to QR according to our proportional statement. And then we have KL. KL is the middle letters. RS is the middle letters. Oop, I was not highlighting. So KL is proportional to RS. Then we have LM. LM is the last 2 letters. SP is the last 2 letters. So LM is proportional to SP. And last but not least, we have JM. JM is the first and last letter. QP is the first and last letter. So therefore, those are proportional. Okay. Oops, I write an R every time for that one. So yeah, that was your answers for number 3 there. Okay. So now let's go to number 4 and let's do some finding side lengths using proportions, which most of your quiz will be made up of. Okay. So number 4 says that the figures below are similar with a scale factor of 2 to 3. find the value of x. So remember that we can write, this is just a ratio, right? And we can also write those as fractions. So we'll do 2 over 3. Remember, proportions are basically, in very simple terms, two fractions that equal each other, and we solve for an x in them, right? So we have 2 over 3. Now, how you're going to set this up kind of has some logic behind it, okay? You can't just put stuff anywhere. It's very, specific reasons, okay? If you think about it, what number is smaller, 2 or 3? You should say 2, okay? Which shape is smaller, this one with the 42 or this one with the x? The 42 is smaller, right? Since the 2 is smaller and on top, then the other smaller one needs to be up at top as well. Okay, that just make sure if you have that logic behind it, that means every single time you should set up your equation correctly. Okay, so the 42 goes up top and then the x goes up bottom. Okay, so then we'll solve for x by doing the cross product property or the butterfly method if you prefer. So we'll do 2 times x. So 2 times x equals 3 times 42. So of course 2 times x is 2x. And then 3 times 42 is 126. Okay. And then we just solve for x. So we divide both sides by 2. And x equals 63. And that's it. Okay. Alright, so now let's move to 5. It says if these figures below are similar with a scale factor of 6 to 5, find the value of x. So remember, we have to write 6 to 5 as a fraction instead. And again, order matters, okay? It wrote 6 first, so 6 needs to be up top. So we'll use the same logic, okay? Which one's the bigger number, 6 or 5? Okay, 6 is the bigger one, and it's up top. So which one needs to be up top on the fraction to the right? The x or the 28? You should say the x, because again, 6 was the bigger number, it was up top. X is a bigger shape, so it needs to be up top. And then 28 will be at the bottom, okay? So then we'll do 6 times 28. 6, 28, parentheses, 28, parentheses, equals 5 times x. So 5x. I just went ahead and simplified that, to be honest. 6 times 28 is 168 equals 5x. Then we divide both sides by 15, not 15, 5. So we divide both sides by 5, and x equals 33.6, because 168 divided by 5 is 33.6. So that's why we got that one. Okay? So those were some easy ones, okay? Let's move on to number 6, where we have multiple things. So this time we don't have a scale factor, okay? This time we have a similarity statement. It says if triangle ABC is similar to triangle DEF, we have to find the value of x. Now, there's 2 ways you can go about these problems always. You see a similarity statement, you see that ABC was written first, so you start with triangle ABC. Or just literally pick any of them and just make sure that you're consistent. Okay, so what I mean by that is, so I'm going to do a little bit of mixture of both of them. I'm going to start with triangle ABC because it's written first. But let's pick starting with 28. Okay, just a random 28. So we want 2 fractions to equal each other, right? So if we look, 28 is line BC, right? BC is the second and third letter. EF is the second and third letter. So those are proportional, okay? So we'll do 28 over 20. And then we have to deal with the x, right? So because I wrote the ABC first, The other one from ABC needs to be in this fraction, okay? Your numbers from the same fraction, the numbers from the same shape should not be in the same fraction for this problem. Okay, so we'll put x here, and then if we look, x was AB, AB is the first two letters, DE is the first two letters. Okay, so x over 25. And you could like flip these around. It could have been 20 over 28, but then it would have to be 25 over x. Okay, so then we'll just start doing some math, cross product property or butterfly method. So we'll do 20 times x. And then 28 times 25. And we'll simplify that. 20 times x is 20x. Then 28 times 5. Not 28 times 5, it's 28 times 25 is 700. Okay? Then we divide both sides by 20. And x equals 35. So that's your answer. So let's go to the next problem. Okay. So number 7 says if PQRS is similar to WXYZ, find the value of x. Again, you can start with the same method of PQR was written first, so I start with that one, or you can just pick any number. Okay. For example, we'll just have some fun. Let's pick a number from this one. Okay, I'm going to do 32. We'll put 32 up top. Okay, and then we'll see what it's proportional to. So 32 is ZY, which is the last two letters. Last two letters over here is RS, which is X. Okay, so it should be 32 over X equals, and then we go back to this one, okay? Because if the top number is from this shape, the other top number needs to be from this shape. So 40, and then if we look, 40 is ZW, which is the first and last letter. First and last letter is PS over there, which is 75, so over 75, okay? And then we'll start doing cross product property. So x times 40, so 40 times x. And we'll do 32 times 75, so 32 parentheses 75. And then of course we'll start simplifying. 40 times x is 40x. 32 times 75 is big old number, 2,400. Then we divide both sides by 40. Those cancel. We get x equals 60. So that's our answer. Alright, so now let's move to the next page because we're not done yet. We always got to do a lot of practice, right? Let's see here. Number 8. Alright, so it says if triangle DEF is similar to triangle HJG, find the values of x and y. So this time we're finding x and y. So the way we set things up kind of have to be specific because you can't have x and y in the same proportion. Okay. So let's start. I always start, if I'm finding two variables, I always start with my x up top because I feel like it just makes more sense so I can narrow down my options. Okay. So x is with HG. Well, HG is the first and last letters. First and last letters over here are DF, which is 12. So x over 12. Okay. And then clearly we can't use y, so we have to use this 15. Okay, so it's equal to, since I put x up top and it's from this shape, I have to put 15 up top as well. So 15. We see that 15 is HJ. Well, HJ is the first two letters. DE is the first two letters, which is 9. So over 9. Then we do our cross product. So we do x times 9, so 9 times x. And then 12 times 15. Okay. 9 times x is 9x. And then 12 times 15 is 180. Then we divide both sides by 9, and we get x equals 20. Okay? Now you can either realize, all right, x equals 20, you plug in here, you can use that fraction to find your y, or just use this one. Okay? Just don't make it harder on yourself. Don't do more work than you have to. So when we're finding y, okay, so y is JG. Erase this. JG is the last two letters, EF's the last two letters. Okay, so we'll switch up my colors. We will do y over 14. Let's just go ahead and use the 15 over 9. Okay, so then we just start cross property. So 9 times y equals then 14 times 15. Okay, clearly 9 times y is 9y, and then 14 times 15 is 210. We divide both sides by 9, and we get y equals 23.3 repeating, so we'll just leave it as 23.3. Okay. All right, so we found x and y, number 8. Let's move to number 9. So number 9 is kind of the same thing, okay? It says the triangle JKL is is similar to triangle NML. Find the values of x and y, okay? So again, I usually like to start with finding my x, okay? So I'll write my x over. So x is on KL. When we look at our similarity statement, KL is the last two letters, ML is the last two letters, so they are proportional. Okay, so it's x over, and then we found out ML right here was 14. So x over 14 equals, and we gotta make sure that we don't use y in our other fraction. So I'm gonna go ahead and pick this 16 because we've already used this one. This one's y, so I'm gonna use this 16 over here. And that has to go, does that have to go in the top or the bottom? You should say the bottom because remember x is from the large triangle and 14 is from the small one. Okay? Big triangle, small triangle, small triangle. Okay? It always has to be like that or it's possible you're going to get it wrong. We don't want that, right? So 16 is from NM, which is the first two letters. Well, the first two letters over here is JK. Okay, so it should be 40 over 16. And we do a cross product property, so x times 16, or 16 times x equals, and then 14 times 40. So 14 parentheses 40. Then, of course, we do 16 times x, which is 16x. And 14 times 40 is 560. Then we divide both sides by 16. And x equals 35. Okay? So we found our x. Let's find our y. Again, if you have already a fraction that you use from these triangles, use it again. Okay? You don't have to make it harder on yourself. So 40 over 16 equals, and then now we're going to have to find y, right? So equals fraction. And is our y going to go in the top or is it going in the bottom? You should be saying bottom because again, 16 is from the small triangle, while y is also from the small triangle. So large triangle, small triangle, small triangle. Okay, just how it works. And then so y is ln. LN is the first and last letter, JL is the first and last letter, so it's proportional to 45. So that's how you should set up your proportion. Okay, and then we're going to solve. So 40 times y, and then of course 16 times 45. 40 times y is 40y, and 16 times 45 is 720. Then we divide both sides by 40, and 720 divided by 40, y equals 18. And that's your answer. That's how you work that problem. All right, number 10. So it says if triangle AGM is similar to triangle KXD, find the value of x. So this time I'm going to go in the fact that it's in this order, okay, just to show you that it works as long as you're consistent. Okay, so say AG is written first. So I'm going to do AG. So 32 over, and we look, AG is the first two letters. Well, KX is the first two letters, which is x plus 3. So 32 over x plus 3 equals, and then we have GM, which is 36. So 36 over, and again, same reasoning, GM is the last two letters, XD is the last two letters. So XD is x plus 6, so we're going to write 36 over x plus 6. And then do the same thing we've been doing, either product property or the cross product property or the butterfly method. Okay, so then we do 32 times x plus 6, 32 parentheses x plus 6 equals 36 times x plus 3. And now these ones you have to be careful because we have to distribute. We have to distribute those numbers into the parentheses. And when we do that, we want to multiply. So we're going to do 32 times x, which is just 32x. Then we'll distribute the 32 into the 6. So we'll do 32 times 6, which is 192, equals, and we'll distribute the 36 to the x, which is 36x. And distribute the 36 to the 3, which is 36 times 3, which would be 108, okay? So then we start combining like terms, solving for x's and whatnot. So again, if it helps you, draw a line through the equal sign. So it helps you show like what is on what side of the equal sign. I always move my x's to my smaller x. No, sorry, I move my smaller x's to my larger x's, okay? So clearly we had 32x and 36x. My 32x is a smaller one, so I'm going to move that to the 36x, okay? So we're going to subtract 32x from both sides. Those cancel out, and then while I'm doing this, I'm just going to bring everything down. Okay, so I'm going to bring the 192 down. Don't forget your equal sign. 36x minus 32x will give me 4x. Bring down my positive 108. Okay. We already moved our x's to the right side. There's no point to move them again. So this time we have to move the 108 to the 192. Since the 108 is positive, in order to move it to the other side, the equal side, we're going to do the opposite of what it is. Okay. So therefore, we're going to subtract 108 from both sides. Those cancel. 192 minus 108 gives me an 84 equals 4x. We divide both sides by 4, and x equals 21. That's my answer. Okay, if you don't have that written down, pause the video and write it down because I have to erase because I don't have enough room. Alright, number 11. If triangle TLY is similar to triangle CHK, we have to find LY. So this time it doesn't necessarily want X as the answer. It wants us to find X and then plug it into LY right here. So first things first, find X. So I'm going to choose the order factor. So TL was written first. So 25, TL is the first two letters, CH is the first two letters. So those are proportional. So I have to write 25 over 10. Let me write a little bit smaller than up here. So 25 over 10 equals, and then of course from that same triangle we have LY, which is 4x minus 1. So write that on top. LY is the last two letters, HK is the last two letters, which is x plus 5. So it should be 4x minus 1 over x plus 5. And then we do the same old cross product property. So we're going to do, let's do 10 times 4x minus 1. So 10 parentheses 4x minus 1. It's really important to use parentheses because you want to make sure you're distributing that 10 into the entire thing. Okay, it's not just 10 times 4x. It's 10 times all of 4x minus 1. Okay, it's important. So then we'll do 25 times x plus 5. So it equals 25 parentheses x plus 5 close parentheses. And of course, then we'll start distributing in the numbers. So 10 times 4x is 40x. 10 times negative 1 is negative 10 equals. Then we'll distribute the 25 in. 25 times x is 25x. 25 times 5 is, let's look at here, 125. Okay. As usual, draw your line down the equal sign if that helps you. If you don't think it helps you, but you still struggle with solving for x, draw the line, okay, just to be safe. So again, I like to move my smaller x to my larger x, so we'll move that 25x over. It's originally positive, so we're going to make it negative. So we're going to subtract from both sides, okay? Then we just start bringing things straight down. 40x minus 25x is 15x. Bring down my negative 10. Bring down my equal sign. These cancel. And I'll bring down my 125. Now clearly we want the x by itself. Okay, the x is already on the left, but we have this negative 10. In order to get on the other side of the equal sign, we have to change its sign. So we're going to change it to positive, so therefore we're going to add it to both sides. Okay, so we have 15x equals 125. Let me write this down here so it doesn't get mixed up with those words. So we have 15x equals 135 because 125 plus 10 is 135. Then we divide both sides by 15 and x equals 9. But that's not what we're looking for, okay? The question didn't ask us to find x, it told us to find Ly. So, what's Ly? Ly is this 4x minus 1 here. So Ly equals 4, and we're going to plug our x in. So 9 minus 1. Okay, so 4 times 9 is 36. 36 minus 1 is 35. And that is finally the answer. If you don't have that written down yet, pause the video because I have to erase. Alright, so let's continue with number 12 now. Also, my boyfriend is texting me and he would like to tell my students that he said hi. So, there's that. Alright, number 12 says if triangle BNB is similar to triangle BRG, BR equals 4x plus 7, and BG equals 18, find the value of x. So clearly it told us some information that they didn't put on the diagram because they want us to do more work, right? So if we look, they said BR, which is this entire line right here, is 4x plus 7. Okay, so we're going to write that on the diagram since they didn't want to do it for us. And then BG is 18. Okay, so since BG, that entire line, is 18, this isn't important, but I am pointing it out because you're going to use this type of logic on your homework, quiz, and classwork. If this entire thing is 18, BG is BV plus BG, right? So clearly VG would have to be 10 because 8 plus 10 gives us 18. Okay, you're going to have to use some of that logic that part plus a part equals the whole. Okay, so don't forget about that. All right, so, and now we have to find x, right? Let's start with the fact that B and V is written first. So I'm going to pick BN, which is 12. And let's see what BN is proportional to. So BN is the first two letters, BR is the first two letters, which is this entire thing, right? Which it told us is 4x plus 7. So over 4x plus 7 equals. And then we got some numbers, but we can't use this 10, right? Because NV is proportional to RG, and they don't give us RG. So we have to use the 8 and the 18. Okay? So 12 is a part of the smaller triangle. So therefore, and we wrote that on top. So therefore, we have to write 8 on top because it's a part of the small triangle right here. And if we look, BV is proportional to BG. So it's proportional, 8 is proportional to 18. Okay, and we start doing our thing, cross product property or butterfly method. So we're going to do 12 times 18. And then we're going to do 8 times 4x plus 7. So 8 times all of 4x plus 7. 12 times 18 is 216. 8 times 4x is 32x. 8 times 7 is 56. Then we start solving for x. So we'll subtract 56 from both sides because the x was already on the right. Those cancel. 216 minus 56. Don't know that off the top of my head. Is 160 equal to 32x. Then we divide both sides by 32. 160 divided by 32 is 5. So x equals 5. So if you're watching the video, I know you have a classwork that's due tonight. So I'm actually going to go over one of the harder problems on the classwork. Okay, give me 1 second to pull it up. Alright, so you have your classwork pulled up now, and I'm going to go to number 6. Okay, so it says, it says triangle RST is similar to triangle YST, find YZ. Okay, in order to do that, we have to find X, right? So since I see well, I saw that RS was written first, but clearly there's no RS, right? So we can't use that. So I'm trying to pick, okay, I see 40, which is ST. Okay, so 40 over, well, ST was the last two letters, and then SZ was the last two letters. If we look, I'm going to erase this. SZ is a small one, right? Which they don't give us, okay? But they give us that this entire thing is 5, and then this small portion right here is 5. So if we do 40 minus 5, it gives us 35, which is SZ, okay? So that's, I wanted to go over that problem because I think some people get confused about that. Okay, so 40 over 35 equals, and then clearly we got the, you look at this mess, Um, 40 came from the bigger triangle. Well, the bigger triangle is this one right here, right? So I have to put 3x minus 7 at the top because big triangle, right? Small triangle, small triangle. Okay, you just gotta stay consistent. And then, of course, sorry, I'm trying to get it together. So 3x minus 7 was RT. RT was first and last. YZ is first and last, which is 2x plus 2. Okay, so we're going to put those over each other. And then you just start solving for x, okay? I just wanted to go how that was set up. And then, let me see another one. Ooh, I really want to go over number 8. So if you flip the page, go to number 8, okay? This one kind of has the same process on when you have to, like, add stuff, okay? So, let's start with 32, okay? So, look at this, okay? This is the small triangle, and then this one is the big one, okay? So it doesn't really give you that this long line, doesn't give you what this long line is, but it tells you that this long line is 32 plus 28, okay? And of course, 32 plus 28 is 60, okay? It also doesn't give you what this one is, right? But it tells you it's x plus 8 plus 21. Okay, so this one's x plus 8 plus 21. And then when you combine like terms, what's 8 plus 21? 29. So this entire thing right here is x plus 29. Okay, it's kind of weird that doesn't go over that in our notes, but you'll have it on your quiz and your homework and whatnot. So I wanted to go over that. So then you just start solving. Okay, I'm going to start with the small triangle. So 32 is proportional to 60, and then x plus 8 is proportional to x plus 9. Okay, because small triangle, proportional, proportional. Okay, and then I want to go over one where you have to do x squared. Let's go over the one right below it, number 10. Okay, I'm just going to set it up and then we might solve it. Let's solve it together, okay? So triangle CSE is similar to triangle YJE. Find EY. Okay, let's start with CE because that's just the first thing I see. Okay, so CE is 18. 18 over CE is proportional to YE, which would tell me is x plus 1. Okay, so x plus 1. It's not always in the best places, right? So that's why you gotta look at the similarity statement. Okay, and then of course so CE was on this triangle, right? Also on this triangle is x minus 2. So I'm going to do x minus 2, which is SE. SE is proportional to JE. So 10 over 10. Okay, so then we start doing our cross product property. We do 18 times 10, which is 180. And then we gotta do x plus 1 times x minus 2, which if you look is two binomials, because bi means two. Okay, there's two binomials being multiplied to each other. So you can either do two methods here, either the box method or the FOIL method. I know a lot of my students do the box, so I'll do the box with y'all. So let's draw our box together. I'm sure yours looks better than mine. Alright, so then we start putting this and this into the box, okay? So we'll put this one on the left side. So x goes into this window, and then 1 goes to this one, right? And we'll put the x minus 2 up top. So x, negative 2. You're splitting it up, kind of. And then this box includes x and x, so what's x times x? Don't forget there's an invisible exponent of 1 there. It's x squared, okay? Then we have x times negative 2, negative 2x, 1 times x goes there, which is just x. And then 1 times -2 goes here, which is -2. Okay, so you just multiplied x plus 1 times x minus 2 all within one box. So let's bring it out of the box. Okay, we're still going to write our 180 equals. Okay, let's bring it outside the box. Actually, I'm going to rewrite this the other way. It won't change anything except for the, because you know when we solve quadratics by factoring, we want to move everything to equal 0. And I think you guys just do better when we move stuff to the left, okay? So we bring all this outside the box. We do x squared minus 2x plus x minus 2 equals 180. Then we start combining like terms. I'm going to make this go away. Hold on 1 second. Sorry. All right, so we combine like terms. Clearly, the like terms here are negative 2x and x. So bring down our x squared. Negative 2x plus 1x, just a negative 1x, or just negative x, minus 2 equals 180. Okay? So then we got to move. So this is clearly a quadratic equation because we have x squared, right? So we solve quadratics by factoring, and the first step in doing that is to set the equation equal to 0. So essentially, we got to move this 180 to the left, okay? It's originally positive, so we're going to make it negative. We're going to subtract 180. And what is its like term over here? Okay, it's not x squared because this one doesn't have an x squared. It's not x because this one doesn't have an x. It's negative 2. Okay, so we're going to subtract 180 from negative 2. Then we start bringing everything down. So bring down x squared, bring down our negative x. Negative 2 minus 180 is a negative 182. I'm going to say 190. Negative 182 equals 0. Okay. And then we got to start thinking about two numbers that multiply to give you a negative 182, but then it's going to have to add to give us a negative 1. Okay, so it's gonna be a lot, right? So it's kind of hard to think of what multiples would be for negative 182. So I'm going to show you a trick. So go to your graphing calculator, okay? You're going to hit this y equal button up top, okay? This button right here. So then clear it, and you're going to put that negative 182 in, and divide by x. If you go to that green button that says alpha, to the right of it, if you hit that, that's going to give you an x. Okay? So then hit second, that blue button, and then graph this top right button. Okay? So graph. Then it gives you a table, right? These are all multiples, basically two numbers that would multiply to give us negative 182. Okay? So now we got to figure out which one's going to give me, add to give me 1. Okay, if you look, negative 13 plus 14, negative 13 plus 14 gives me a positive, yeah, it gives me a positive 1, so I need to go up one more. We got to do negative 14 plus 13 to get negative 1, okay? So then we have our two sets of parentheses equal to 0. We want to put an x in each of them because x times x will give us our x squared. And then we know we're going to use 13 and 14. The 13 has to be positive and the 14 has to be negative. Okay? And then we got to do step 3, which is set each factor equals 0 and solve for x. So x plus 13 equals 0. X minus 14 equals 0. And then we start solving for x. So we subtract 13 from both sides. We get that one of the x's is negative 13. Then we go over here. We'll add 14 to both sides. Get x equals 14. Now, if we look at our problem, there's clearly like really only one x, right? So, which one makes the most sense? Can a side be negative? No. So that's not your answer. X equals 14 is your answer. Okay, so if you get two answers and one is a negative when you're doing solving quadratics by factoring, pick the positive number every time. Okay, for these type of problems. So yeah, I think that's all I'm going to go over. Hope you guys have a great day.